This video is going to discuss a battery pack with weak cells, but the cells aren't destroyed. They're just weak and they don't charge properly. So let's get started with this. First, I removed the battery from the aluminum case, and I unwrapped this protective wrapping to view the positive end of the battery, which is shown here. Mid shot of the battery showing the whole length of the battery, and then the negative end of the battery, which has the BMS located on it. Here's the BMS part numbers for those who may be interested. Here you can see the BMS cell plug. These are the wires connected to the battery. Pin 1 is on the right hand side, the red wire in this picture, and pin 14 is on the left hand side, the black wire. So when we start from the right hand side of this picture, the first white wire is the negative side of the uppermost battery group. And it continues going down the battery group so you get to the end, which is the negative side of the battery group. This has nothing to do with power for the BMS. It's just the sensing of the BMS of the battery condition, the various cell states. We found 2 cell groups. There's 4 batteries in each group. So we found 8 batteries at the positive end of the battery assembly. Only had 1.59 volts instead of the normal 3.7 volts across them. So those 2 cell groups are defective. If you look over here, you notice we also found that this battery group right here was only 3 volts. And the rest of the batteries were running 3.6, 3.7. So basically we got 3 cell groups that aren't charged properly, and the BMS can't deal with that. We're going to use this bench power supply, which only goes up to 30 volts, to shock treat the weak cells and wake them back up. We shocked the first 2 groups of the battery on the positive end, shown here with X's on them. We shocked them by setting maximum voltage and limiting the current to 5 amps. And then we simply applied the source across the batteries until their voltage slowly approached 4 volts. Once it got above 3.9 volts, we removed the charging for that shock session. Remember, there's 4 batteries in each group, so each battery is only getting 1/4 of the 5 amps, which is what, 1.5 amps, 1.25 amps. So we weren't damaging the battery with excessive current. Next, we focused on waking up the 3-volt cells shown here. The cell packs are separated by insulators, so you have to probe between the end of the cell and the insulator to apply the voltage across the cells. So these cells are all raised to 3.9 volts also, with the shock charging. In this picture, I want you to notice this black wire here. That's the negative end of the battery electrically. Not physically, but it's electrically the end of it. So this will be used in our next discussions. The alligator clips in this picture demonstrate how the power supply was connected to the top 7 cell groups to charge them up to 7 times 4, 28 volts. So this is how I charged the top half of the battery, because I only had a 30-volt charger. Notice that the blue box there, that says that those cells aren't included in the top half of 7 cell groups. Once again, I charged until we reached approximately 4 volts per cell, and then I terminated the shock treatment on the top 7 cell groups. I don't have a picture of charging the bottom 6 cell groups, so all you do is take this black alligator clip off the terminal right here and move it down here to this terminal. That's the negative end of the battery. Then you take the red charging alligator clip and replace where the black one used to be. And now you're looking at 6 times 4, 24 volts. You want to force charge these to 24 volts. And that's how you charge the lower half of the battery with a 30-volt power supply. After allowing to set overnight 24 hours, the entire battery now measures 51 volts. When I started, it was like 46 volts. So I think we've made a vast improvement here. And I do believe this battery will perform to factory standards. In the next video, I will assemble this battery, put it in a bike, and report the results.